Okay, let's do question B. So just like when you're subtracting your regular base 10 numbers, you are going to line up your digits according to their place values. Okay, so I'm just going to do that here. Once you're finished with that, you can go ahead and start subtracting just like you normally would. Okay, so we're going to start from the rightmost column. Now, there is no number to subtract 1 from, so what we're going to do, just like for regular base 10 subtraction, we're going to borrow 1. Everything else is basically the same. Between binary and base 10 subtraction, everything else is the same. The only difference is when you're borrowing 1. Now, you're not going to be writing just 1 in the next place value. You are going to be writing 1, 1. Okay, so we still need to get our 1 to this place value. So I'm going to take 1 again. And I'm going to write 1, 1 in the next place value. And we repeat the process until we get the 1 to be in the place value where we want it to be. Okay, so 1, 1 minus 1 is going to lead us to just cross out this 1 and you're left with 1. Okay, next place value, we have, remember this 1 is no longer here, we crossed it out. So we have 1 minus 1 is going to give us 0. Next we have 1 minus 0 is 1, 1 minus 1 is 0 again. And there's no number to subtract this 0 from. And we also have no digit here to subtract 1 from. So we're going to just bring it down. Sorry. Okay, so our final answer is going to be 1, 0, 0, 0, 1. And remember this part is important as well. Base 2. Okay, if you want to double check your answer, what you can do, you can convert the numbers that you're given to base 10 and subtract them, add, multiply whatever it is in base 10. Then whatever base 10 answer you get, you're going to convert that back to either base 5 or binary, depending on what your question is, to see if you get the same base 5 answer or binary answer. Okay, so that's one way you can double check your answer. All right, let's move on to question C. All right, just like for normal multiplication, you're going to start by lining up your numbers according to their place value. Then we're going to go ahead and multiply. Okay, so 4 times 2 is 8, but remember we cannot write 8 because we're working in base 5. So just like before, we're going to convert that to base 5 and we are going to find out how many groups of 5 can we get from this number. Okay, so it's one group of 5 and remainder 3. So we're going to put down the remainder and carry that 1 to the next place value. 4 times 2 is 8. 8 plus 1 is 9, but we can't write 9, so we're going to change that to base 5. All right, so we can get one group of 5 and remainder 4. So we're going to put down that 4 and carry the 1 to the next place value. Okay, so we're just going to repeat this process until we have basically multiplied all of the digits. That's basically it. All right, so 2 times 2 is 4. 4 plus 1 is 5. Can't write 5. We know that there are one group of 5 in 5, and that will leave us a remainder of 0. Leave us with a remainder of 0. So we're going to carry that 1 over to the next place value. Sorry. 3 times 2 is 6. 6 plus 1 is 7. We can't write 7, so as usual, we're going to find out how many groups of 5 can we get from 7 and put down the remainder. Okay, since we don't have any more place values to carry this to, we're just going to put down the 1, 2 at the front of the number. All right, so remember 7 would be 1, 2 in base 5. Okay, just like with regular multiplication, you know that you're supposed to add your 0 to the next row before you multiply by the next digit. All right, so 4 times 4 now. That's 16. We can't write 16, so we're going to find out how many groups of 5 can we get from 16. That would be 3, and we would have a remainder of 1. Okay, so 5 times 3 is 15. 15 from 16 would give you a remainder of 1. So we're going to put down that 1 and carry 3. Remember, we got 3 groups of 5, so we're going to be carrying 3 to the next place value. All right, I'm going to have to erase the previous markings so that we don't get confused. All right, next step. 4 times 2 is 8. 8 plus 3 is 11. We can't write 11, so we're going to find out how many groups of how many groups of 5 can we get from 11? That's going to be 2. And 5 times 2 is 10. 10 from 11 is going to give you 10 from 11 is going to give you a remainder of 1, right? So we're going to put down the 1, carry the 2. Sorry, I almost said 1. Remember, we have 2 groups of 5, so we're going to be carrying 2 to the next place value. All right, next step, we're going to wait, hold on. Did I make a mistake here? 16. Oh, hold on. I made a mistake. I have to go back. Going back. Okay, remember, this is the place value we were supposed to multiply next. Okay, so it should have been 4 times 4 is 16. 16 plus 3 is 19. So this should have been all right, just a minor computational error. Okay, so we would get 3 groups of 3 groups of 5, sorry, from 19, and we would have a remainder of 4. Okay, so I'm going to change this to 4, and again we have to carry 3 to the next place value. Okay, so 2 times 4, this is what I made a mistake with. I moved on to 2 before I multiply this 4. All right, so 2 times 4 is 8. 8 plus 3 is 11. We can't write 11, so we're going to write that as a base 5 number. Okay, so 2 groups of 5, remainder 1. So we're going to we're going to write the 1 and carry 2 to the next place value because there are 2 groups of 5. Okay, last one. We have 3 times 4 is 12. 12 plus 2 is 14. Can't write 14, so we're going to write that in base 5 as there are 2 groups of 5s in 14, and that would give us a remainder of 4. Okay, there are no more place values for us to carry that 2 to, so I'm just going to write down 2, 4 at the start of the number or at the front of the number, and then we add. Now when you get to the addition part, remember we're adding in base 5, so we have to keep in mind we cannot write any number that is 5 or more, so we always regroup at 5 when we get a number that is 5 or more. Okay, so 3 plus 0, 3 is allowed, so I'm going to write that. 4 plus 4 is 8. We can't write 8, but we know 8 has 1 group of 5 and remainder 3. So I'm going to write down 3 and carry the 1 to the next place value. All right, 1 plus 1 is 2. 2 is allowed. 2 plus 4 is 6. 6 is not allowed, but we know that 6, okay, it's not written here. I'm going to do this one mentally. 6 has 1 group of 5, remainder 1. So we drop the 1, carry the other 1. Okay, 1 plus 1 is 2. 2 plus 2 is 4. 4 is allowed. So this is going to be our final answer. And remember, the subscript 5 is very important. It's to show that this is not 41,233. It's 41233 base 5. Okay, I'm going to have to snip this question. All right, let's talk about how we convert from one number-based system to the other. All right, let's say we have 40, I almost said 40. 40 base 5 to base 10. Now, when you want to convert to base 10, you're going to need the powers of 5. All right, so whatever number-based system you're converting from, you're going to be writing the powers for that number. So if you're converting from base 5, you're going to write the powers of 5. If you're converting a number from base 2 or binary, you're going to be writing the powers of 2. Okay, so since this is base 5, we're going to start writing the powers of 5. All right, so you're going to start with not 5. You always start with 1, sorry. And you're going to write that on the right side. Then you're going to keep multiplying by 5 until you get a number that is bigger than the number that you're converting. Okay, so 1 times 5 is 5. So you're going to write from right to left. You're going to write your powers from right to left. Your powers of 5. Sorry for repeating it so often. You're going to write your powers of 5 from right to left. Okay, 5 times 5 is 25, and 5 times 25 is 125. Okay, now that we have a number that is bigger than 40 in this case, we can stop writing. Okay, next thing we're going to do, we are going to match the powers that we have to each digit. This is what I mean. Okay, so you're going to start from the right. So you're going to write 0, then 4, and you're going to multiply each digit by its corresponding power. Okay, so you're going to multiply these. So this is going to give us 20, and this is going to give us 0. Okay, once you're finished with that, you're going to go ahead and add. Okay, so this is going to give us 20 base 10. All right, so how do we convert from base 10 to base 2? Now, what you're going to do, you're going to start by writing out your powers of 2 until you get a number that is bigger than the number you're converting. And when you're writing out your powers of 2, you're going to be doing the same thing. So you're going to start with 1, and you're going to start writing from the right to left, right to left, and you're going to keep multiplying by 2. So 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, then 16, then 32. I think I'm going to run out of space. All right, let me create a little more space. Okay, we're going to do a lot of writing for this one. All right, a lot of powers to be written here. 16, 32, 64. This is a big number. 64. Next one I think is 128. Let me check to be sure. All right, 128 times 2. Think I'm going to run out of space. 256. All right, halfway there. All right, 512 finally. Okay. So since we have a number that is bigger than 230 base 10, we can stop writing the powers. Now, when you're converting to binary, you are going to, the method I prefer is the subtraction method. There's another method where you divide by 2, but I prefer what is called the subtraction method. So to use the subtraction method, you're going to start by subtracting the biggest number that is less than the number that you're asked to convert. Okay, so what is the biggest number here that is less than 430? That would be 256. So we're going to subtract 256 from 430. And as soon as you subtract that number, you're going to circle it, and you're going to understand why we have to circle it later on. You're going to need to keep track of the numbers that we subtracted. Alright, when I subtract this, I get 174. And basically, you're going to be repeating the same process until you have 0 as the remainder. That's basically it. Alright, so again, we're going to choose the biggest number that is less than 174 in this case. Alright, the biggest number that is less than 174 would be 128. So we're going to subtract again. And we're just going to keep repeating this until we get 0 as the remainder after we subtract. Okay, when I subtract this, I get 46. Alright, so you notice where I circle as I subtract. So as soon as I subtract the number, I circle it. So please, when you're doing the subtraction method, don't forget to circle the number that you subtracted, because it's going to be very important for your final answer. Okay, what is the biggest number that is less than 46? That would be 32. Okay, so we're going to say 46 minus 32, and you should get 14. So the remainder is still not 0. We're going to keep going. The biggest number that is less than 14 is 8. And we get 6. Okay, still not 0. The biggest number that is less than 6 would be 4. So we're going to subtract again, and that gives us 2. The biggest number that is, alright, when you get to this stage, I said that you're going to choose the biggest number that is less than whatever number you're left with. Actually, you can also subtract the number if it is equal to your remainder. So if you find that there is a number that is equal to the remainder, you can subtract that number as well. Okay, so you're going to choose either the number that is equal to your remainder, or the number that is the biggest number that is less than your remainder. That's what I'm saying. Okay, so 2 is equal to 2. So I'm going to circle that 2, and I subtract. Or you're going to choose, another way to think of it is you're going to choose a number that can be subtracted from your remainder. So the biggest number that can be subtracted. Yes, the biggest number that can be subtracted from your remainder, right? Without giving you a negative number. Okay, so we have not 1, that's 0. And since we have a remainder of 0, we can stop subtracting. Okay, the last step you're going to do, well, it's the second to last step. The second to last step is you're going to write ones above the numbers that you circled. Okay, so this is why it's important to remember to circle the number as soon as you subtract. And for the numbers that you did not circle, you're going to fill those in with zeros. Alright, so this is a very big number. Alright, the 0 at the front of the number doesn't really affect anything, but always include the zeros that are at the end of the number. So the zeros at the front of the number don't really affect the value, but the zeros at the end are very important. Okay, so our final answer for this one is going to be So just copy everything that you have up here. 0, 1, 1, 0. And remember to look back at the sequence of numbers that you have up here, because that is very important. So if we get one part of it wrong, we're writing a completely different number. And our subscript 2 is very important as well. Okay, so this is not, that would be what? 11,010,110 if we forgot the subscript 2. So this is not base 10, it is binary or base 2. So we have to remember to include our subscript 2. Alright, last one we have here is converting from binary to base 10. It's practically the same. You're basically doing the same thing that you would do when you're converting from base 5 to base 10. But this time, since it is base 2 that this number is in, we're going to be writing the powers of 2 instead, starting with 1. Alright, let me snip this question. So the methods for converting from base 5 to base 10 and for converting from base 2 to base 10, it's practically the same. The only difference is the powers that you're writing. So we're not going to be writing the powers of 5, we're going to be writing the powers of 2, since this number was given in base 2. Alright, so a part of it was cut off here, but that was base 2. Alright, so starting with 1 on the right, and the order in which you write it is very important. So do not start from left to right. You're going to write from right to left, starting with 1. Okay, we're going to keep multiplying by 2 this time, since we're writing the powers of 2. Okay, so this is going to be 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. 16. Also, what should I say? Okay, here's another way to do it. You can write the number first. Okay, you can write the number first, but just keep in mind you're going to be writing this number from left to right, but when you're writing your powers to match each digit in the number that you're given, you're going to write them from left to right. So just pay very close attention to the way you write your powers. Once you do that, then you should be fine. So you're allowed to write the number first, but just remember not to mix up the way you write your powers, because if you don't write them in the correct direction, you're not going to get the correct answer. Okay, so we can continue. What you're going to do, just write a power for each digit in the number. Okay, so right, we have 2 more digits to write the powers for. So it's 32 and 64. Okay, just like when we're converting from base 5 to base 10, we're just going to multiply each digit by its corresponding value. And converting from binary to base 10 is much simpler, because we know any number multiplied by 1 is itself. So we're going to end up with 1, 2, 4, 16, 32, 64. And once you're finished multiplying each digit by its corresponding power, you are going to just add what you have left. So add up all of the products you'll get after multiplying. Alright, so we're going to add up everything here. Alright, my hands are getting tired. Let me see if I can quickly just finish writing the addition signs. Alright, so we're going to add up everything. And that is going to give you 119. Okay, so we're allowed to call this 119 because it is in base 10. If it was not in base 10, let us say this was, well, 9 cannot be used for any other number-based system. Or maybe 12. But since we're talking about base 10, we just call it how we normally call it, since we use the base 10 system every day. Alright, so our final answer is going to be 119. And remember, for base 10, if there's no subscript number there to show the base, you can safely assume it is in base 10. So that is why when you're writing a number in binary or base 5, it is important for you to write your subscript 2 or your subscript 5 respectively. Alright, so you can leave it as is, or you can write subscript 10. And that's basically it.